Mhm.
Because I thought you and I do the series space and then find the facts of it. That's it though. I'm not here to water bottle.
Mhm.
What?
Since we have two things multiplied together equals 0. Yeah. Add 7. Mm-hmm. Yep, you're right there. You just need to finish factoring. All right, guys. All right, guys. So we're going to go on and get started. We're going to go on and get started for today. So we're continuing what we did last Thursday and Friday, solving these rational equations. Solving rational equations. Now, there's a few things we have to do when solving rational equations. First, we need to make sure all the denominators are factored as far as possible. They need to be in factored form. And for us here, x plus 1, 2x and 2x are factored. And since they are factored, we can find our restrictions. And the restrictions are going to be any value of x that will make the denominator be 0. Because any value of x that makes that denominator 0, we have to exclude. It cannot be that because we cannot divide by 0. Now, one of the places where the denominator could be 0, thank you, is x plus 1. And the other place is 2x. So any value of x that's going to make x plus 1 or 2x be 0 has to be excluded. Now, even though 2x is written twice, shows up twice, the value of x that would make it be 0 is going to be the same value, so we do not have to solve for it twice. Now, for our x plus 1, first thing we're going to need to do is subtract 1 from both sides, because our 1 minus 1 would be 0. Giving us x, or leaving x by itself, is equal to 0 minus 1 is going to be negative 1. So it tells us if x is equal to negative 1, guys, focus in. If x is equal to negative 1, we'd have a division of 0. It does not work. We're going to do the same thing for 2x. But the first thing we're going to do here is divide both sides by 2, because 2x divided by 2, the 2 divided by 2 is going to be 1, leaving us with just x. And 0 divided by 2 is going to be 0. So it's telling us x cannot be 0 or negative 1. If we get a solution of 0 or negative 1, we have to throw it out. Those values do not work. Questions on how we found our restrictions? Now at this point here, we need to figure out what we need to multiply everything by to get those denominators to simplify, because it's going to be a lot nicer to work with non-fractional terms. What is one thing we can multiply everything by? 2x. And we're going to start by multiplying everything by 2x. And when we multiply these fractions by 2x, we're multiplying it on top. And this is nice because the fraction on the far right, we're going to get 3 times 2x over 2x. And our 2x over 2x will simplify to 1. They're going to simplify out. I'm going to check my middle term. And same thing. We'll end up having 2x over 2x. Our 2x divided by 2x is 1. They will simplify out. However, our far right term, the 2x and x plus 1 are not like terms. They're not the same, so they won't cancel out. Do we still have terms left on bottom? Well, yes. We have what? X plus 1. So that means we're also going to have to multiply every term by x plus 1. Now this far left term, the x plus 1 and x plus 1 will simplify. The x plus 1 won't simplify with either of the other two because they don't have x plus 1 on bottom. But by multiplying everything by 2x and x plus 1, it causes all three denominators to simplify out. They reduce to 1. And what that leaves us with in the first expression, we still have the 3x and the 2x minus 5, and it's being multiplied by x plus 1, and this is equal to 3 times our x plus 1. So multiplying by that 2x and x plus 1, got all three denominators to simplify, all three denominators to reduce down, leaving us with this here. Any questions on this so far? Questions on this so far? Questions? Now we need to solve for x. So the first thing we can do for solving for x, focus in, is start distributing and multiplying these out. So the first one we can do here is 3x times 2x. Now our 3 times 2 is going to be 6, and our x times x is going to be x squared. Now our next set of parentheses, we're going to have to distribute that -5. Now -5 times x is going to be -5x. And -5 times 1 is going to be -5. Equals, this last set of parentheses, we're going to have to distribute this 3. 3 times x is 3x. And 3 times 1 would give us plus 3. So we have 6x squared minus 5x minus 5 is equal to 3x plus 3. Questions on how we got here? Now, because we do have quadratic terms, we have these x squared terms, we need to get this equation equal to 0. Now, how we move the terms from one side to the other doesn't make a difference. We just need to get it equal to 0. Now, I always try to move the terms so that in this case, the x squared term, the variable with the biggest exponent, is positive. So the first thing we can do is we can subtract 3x from both sides. We could have also subtracted 3 first. It doesn't matter which. But if we subtract 3x from both sides, -5x minus 3x, -5 minus 3 is going to be -8x. We still have our -5. On the right-hand side, our 3x minus 3x would be 0, leaving us with our 3. Now, since it's not equal to 0, we've got to move the 3 next. And to move that 3 from the right side to the left, since it's positive, we're going to have to subtract 3. Because our 3 minus 3 here would be 0. And on the left-hand side, we'll still have the 6x squared. We'll still have the -8x. But our -5 minus 3 is going to give us -8. Questions on how we got everything on the same side? So we have 6x squared minus 8x minus 8. Questions on how we got here? Now at this point here, we need to solve for the value of x. And to do that, we're going to factor. And to factor this, the first thing we're going to look for is a greatest common factor. We're looking for a number or term that is in common with all three, that's divisible by all three. 2. All right, guys, let's focus in. So 2 is the greatest common factor. It's the biggest term, the biggest number we can divide into all three. And we're going to divide it out and put it out front, because our 6x squared, 6 divided by 3, 2 is going to be 3. Telling us that we have 3x squared. Our 8x, if we factor that 2 out, divide it by 2. 8 divided by 2 is going to be 4, giving us -4x. And if we divide that 8 by 2, we get 4, because what we're doing is dividing that 2 out. We're factoring it out. We're dividing each term by 2. So our 6 divided by 2 is 3. Our 8 divided by 2 is 4, and our 8 divided by 2 is 4. And doing that's going to help us be able to factor this a little bit nicer. So now what we're factoring or having to factor left is our 3x squared minus 4x minus 4. So we'll put our two sets of parentheses with three spaces. If the third term sign is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Well, here, since our third term, this 4 is negative, it tells me that the signs are opposite. One's going to be positive, and one's going to be negative. And after we get the signs, we're going to find the factors of the first and third terms. So our first term is 3x squared. The only factors of x squared are x and x. The only factors we can use for x squared. And our only factors of 3 are 3 and 1. So we just need to put the 3 in front of one of the two x's. So we get 3x and x. Now our factors of 4, our third term, are 1 and 4 or 2 and 2. Which one do we want to try first? 1 and 4. And the last thing we want to do is check and make sure we got the correct factors. So we're not going to check for the first or third term. We're checking to make sure that middle term matches, is the correct middle term. Now 3x times negative 4 is going to be negative 12x. Our 1 times x is going to be plus x. And negative 12x plus x is negative 11x. Unfortunately, that's not the middle term we want. So the next thing we can do is switch to 1 and 4. And we can check this again to see if we got the correct middle term. All right, guys, focus in. 3x times negative 1. 3 times negative 1 would be negative 3x. 4 times x is going to be plus 4x. And negative 3x plus 4x is going to be positive 1x. That is not the middle term we wanted. So since we've tried every combination of 1 and 4, we'll need to switch to 2 and 2. And we can check this again. 3x times negative 2 is going to be negative 6x. 2 times x is going to be plus 2x. And negative 6x plus 2x is negative 4x. So that is the middle term we wanted. So it's telling us that 3x plus 2 times x minus 2 are the correct factors for our 3x squared minus 4x minus 4. Questions on how we got here? Now, since we have two or more things multiplied together to equal 0, one of these is going to have to be 0. Either 3x plus 2 is going to be 0, or our x minus 2 is going to be 0. One of these two has to be 0. Since we're multiplying them together to be 0, one of them has to be 0. Now our 3x plus 2, the first thing we can do to solve this here is going to be to subtract 2 from both sides. Because our 2 minus 2 would be 0, leaving us with 3x equals 0 minus 2 is going to be negative 2. And then lastly, we're going to divide both sides by 3, telling us x is equal to negative 2/3. That's one of our solutions. The other thing we have to do is our x minus 2, we need to add 2 to both sides, because our negative 2 plus 2 will cancel. And 0 plus 2 is 2, telling us x is equal to 2. So if x is equal to 2 or negative 2/3, both of those will make the original statement true. Both of those are our solutions. Questions on how we found either value of x? Are either of these values of x a restriction? No, so both of these solutions work. And if we wanted to make sure we could go back, plug them into the original statement, see, are both sides equal? Are both sides the same value? And it will make both of these sides, both sides of this equation, true. Questions on this here? Questions on this so far? Are you ready for the next one? So, we have 4x plus 1 over x plus 1 is equal to 12 over x squared minus 1 plus 3. Now, one nice thing about this problem is that we don't have 3 fractions. We only have 2. But one thing that is different, something we haven't had up to this point, is that middle denominator, that x squared minus 1, is factorable. If one of the denominators, or if multiple of the denominators are factorable, we need to factor. Now, x squared minus 1 does factor, and it's actually a difference of perfect squares, because we have 2 terms being subtracted. X squared, x times x gives us x squared, so it is a perfect square. 1 times 1 gives us 1. And our difference of perfect squares are a squared minus b squared, factors to a plus b times a minus b. In this case here, x squared minus 1 is going to factor to x plus 1 times x minus 1. Now, factoring those helps us be able to know what we need to multiply it by so we don't add any extra factors, and it helps us with finding the restrictions. Because our denominators, we have 3 spots where x could be 0 or cause a value of 0. One of them is x plus 1. And even though it does show up 2 different times, shows up in 2 places, we only need to solve it once, because both of those places will have the same value. And the other spot is x minus 1. Now, to solve x plus 1, to see its restriction, we would subtract 1, telling us if x is equal to negative 1, we'd have a division of 0. It does not work. Our x minus 1, we would need to add 1 to both sides. And that's telling us if x is equal to positive 1, we'd have a division of 0. It does not work. So for us here, x cannot be negative 1, and x cannot be positive 1. Questions on this here? Now at this point here, we need to figure out what we need to multiply everything by to get these denominators to simplify out. Now again, we talked about this last week. We could go about finding the least common denominator, our least common multiple, and then multiplying through, or we can take it one term at a time. So if we look at the left expression, its denominator is what? X plus 1. So to get that denominator to simplify, to get it to reduce, I'm going to need to multiply by x plus 1. Now we're multiplying everything by x plus 1, so we're not changing the equation. We're just changing how it looks. We're scaling it up by a factor of x plus 1. Now on the far left, when we do this, we would get x plus 1 over x plus 1. And since they're being multiplied on top, we can simplify with the x plus 1 on bottom. It would reduce to 1. They would simplify out. Now let's check if there's anything else simplified before we move on to our next term. If we look at the middle expression, it's x plus 1 over x plus 1 would reduce. And our only other term here is the 3. But because the 3 does not have a denominator, doesn't have a bottom of a fraction, nothing's going to reduce, and that's perfectly fine because there's nothing for it to reduce to. We don't need it to simplify. Questions on this so far? Are all the denominators simplified? No, the middle one has an x minus 1. So that means we'll also have to multiply everything by x minus 1. So our least common denominator that we had to multiply by was x plus 1 and x minus 1. Because now that middle term, the x minus 1 and x minus 1 will cancel. And that was the only thing left on bottom. We don't have to multiply it by anything else. This is what we have. Now at this point here, we can see what's left. In our first expression, we'll have the x plus 1. And it's being multiplied by x minus 1, because those are the only two terms left on top. Our middle expression, we do have the 12, but the x plus 1 and x minus 1 we multiplied it by simplified with what was on bottom. So the only thing we have left is 12 for that there. Plus 3 times x plus 1 times x minus 1. We do have both terms there. Questions on how we got to this point here? Now we need to start simplifying these parentheses. So on the left-hand side, we're going to need to distribute the 4x first. 4x times x is going to be 4x squared. 4x times negative 1 is going to be negative 4x. 1 times x is going to be plus x. And 1 times negative 1 is negative 1. So on the left-hand side, when we finish distributing the 4x plus 1 to the x minus 1, we get 4x squared minus 4x plus x minus 1 equals 12 plus. We have the 3 times x plus 1 times x minus 1. It might be very tempting to want to multiply the 3 with the x plus 1 and x minus 1. We cannot do that because there's only one 3 and there's two terms. So we can multiply the 3 by the x plus 1, or we can multiply the 3 by the x minus 1. We can't do both because there's only one 3 being distributed across two terms. However, we can do the x plus 1 times x minus 1 first. And we know that should factor to what? Multiply it back together to be x squared minus 1. So let's see what this does. X times x is x squared. X times negative 1 would be negative x. 1 times x is going to be plus x. And 1 times negative 1 is negative 1. Now the next thing we can do is start combining like terms. On the left-hand side, our negative 4x plus x would be negative 3x. Still have the minus 1, so we'd have 4x squared minus 3x minus 1 equals 12 plus 3 times, well, our negative x plus x would be 0, telling us that we have x squared minus 1. Now, we could have actually jumped straight from x plus 1 times x minus 1 to x squared minus 1. Because at the starting problem, we factored the middle term, that x squared minus 1, to x plus 1 times x minus 1. So they should multiply together to get us back there. But if we don't notice that this factored here and it's going to go back, even if we don't, we can still multiply them together and we will get the correct expression. Now, before we can start moving things from one side to the other, we still have that one set of parentheses left to simplify. We still need to distribute this 3 to the x squared. 3 times x squared is going to be 3x squared. 3 times negative 1 is negative 3. Now, after doing that, we do still have some like terms. Because our 12 and negative 3 are like terms, 12 minus 3 is going to give us Do we have all of our like terms together on both sides, on either side? Yeah. There's no other like terms on either side of the equal sign. So now we can start moving things from one side to the other. Now I try to keep the x squared term positive if at all possible. If not, or it's easier to move everything to the other side, I go that route. If I can keep the variable with the biggest exponent positive, that's my first goal. If it's less moves to move it the other way, that's fine because it's easy to adjust a sign change by multiplying or dividing by -1. So the first thing we can move is what? We can subtract 3x squared. We could have subtracted the 9 first. It really doesn't matter because if we don't, it's going to go next. 4x squared minus 3x squared is going to be 1x squared. And our 3x squared minus 3x squared would be 0. Then we're going to move the 9 by subtracting it from both sides. Giving us x squared minus 3x minus 10. Doesn't matter which one we did first, because if we subtracted the 9 first, it would have given us 4x squared minus 3x minus 10 equals 3x squared. Subtract the 3x squared, we still get to the same spot. Questions on how we got to x squared minus 3x minus 10? So the next thing we can do is we need to solve this. Now this is factorable. Now again, the first thing I would look for is the greatest common factor. But there is no greatest common factor between these three terms. One of the big giveaway or indicators that there's not, the x squared term does not have a number in front of it, and the 10 does not have a variable. So we'll have our two sets of parentheses with 3 spaces. Since that third term is negative, the signs are what? Opposite. One's going to be positive, one is going to be negative. X squared, the factors of the first term. Well, the only factors of x squared are x and x. Now our factors of 10. 1 and 10, or 2 and 5. Which one do we want to try first? 2 and 5. And we can check this here. X times -5 is going to be negative 5x. 2 times x is going to be plus 2x. And negative 5x plus 2x, negative 5 plus 2 is negative 3. Negative 3x, that is the middle term we wanted. So now we do have two things multiplied together that equal 0. And according to the zero product property, the only way we can multiply 2 or more things together and get 0 is if one of those two is 0. So that's telling us that either x plus 2 is 0 or x minus 5 is 0. For our x plus 2, we would subtract 2 from both sides, telling us that one of our solutions is -2. Our x minus 5, we would add 5 to both sides, telling us that x is equal to 5. So if x is equal to -2 or x is equal to 5, those are our two solutions. Is either one of these two a restriction? No. So both of these solutions work. Questions on this here? So this here is the last one we're going to do today. We're going to finish the note sheet tomorrow. Now the first thing we need to do is make sure the denominators are factored, because if we don't and we multiplied everything by the x minus 3 x plus 3, and x squared minus 9, we're adding two extra factors we don't need. We're adding two extra terms, two extra solutions that aren't required. Because our x squared minus 9 is a difference of perfect squares. We have two terms being subtracted. One more time. So nothing yet. Because x squared minus 9, we need to factor it. In parentheses. So x squared minus 9 is going to factor to what? X plus 3 and x minus 3, because it is a difference of perfect squares. We have two terms being subtracted. X squared is x times x. 9 is 3 and 3. And that also helps us find our restrictions. Because even though we do have 5 terms in the denominator, we only really have 2. Because we have x minus 3 and x plus 3. And if we solve our x plus 3 by subtracting 3 from both sides, we see that if x is negative 3, it would make our x plus 3 terms be 0. We cannot have that. And our x minus 3, we add 3 to both sides to get x by itself. And it tells us for our x minus 3 terms, if x is equal to positive 3, both of those would be 0. We cannot have that. We cannot have that division of 0. So now that we have our restrictions, let's see what we need to multiply everything by. So that's one expression we need to multiply the whole thing by. X minus 3. And if we multiply everything by x minus 3, our far left rational expression, the x minus 3 over x minus 3, would reduce. Our middle expression, the x minus 3 and x minus 3 would reduce. And in the far right rational expression, nothing's going to reduce because we have x minus 3 over x plus 3. But that also tells me that I do need an x plus 3. Because for the far right one, x plus 3 over x plus 3 will reduce. In the middle, the x plus 3 over x plus 3 would reduce. In the far left, the x plus 3 won't reduce with anything because there's nothing left on bottom. And what that leaves us with is 6 times x plus 3 is equal to 8x squared minus 4x times x minus 3. Questions on this here? Again, the biggest thing I would say with solving these here and simplifying is taking it one expression at a questions on how we got to this point here. Now, to solve this here, we need to simplify these parentheses. So on our far left, we're going to multiply the 6 through. 6 times x is going to be 6x. 6 times 3, 6 times our positive 3 would be plus 18. Now our 8x squared, we don't have anything being multiplied to it, nothing we need to reduce there yet. But we do need to distribute this negative 4x. Negative 4x times x is going to give us negative 4x squared. And our negative 4x times negative 3, the negative and negative make a plus. 4 times 3 is 12, and we still have our multiplication of x. Now, before we can start trying to get this equation equal to 0, we do need to combine like terms. Our 8x squared and 4x squared, 8 minus 4, is going to be 4x squared. Plus 12x. And really, that was the only thing we needed to combine on the same side, the only like terms we had on either side. And since we do still have an x squared term, we need to get this equation equal to 0. And to do that, doesn't matter where we start, we can subtract 6x from both sides. Our 6x minus 6x would give us 0 there, leaving us with 18, is equal to 4x squared plus 6x. Then we're going to need to subtract 18 from both sides. 18 minus 18 will be 0. Our left-hand side will officially be 0. Now, because there are no like terms with our negative 18 to subtract from, it's just going to be minus 18. Questions on how we got to 4x squared plus 6x minus 18? Now, we need to factor this to be able to solve. Because if I can rewrite this as 2 or more things being multiplied together to equal 0, we can just set each of those things equal to 0 and solve. First thing we always want to look for is the greatest common factor. Is there a common number or term in all 3? Bless you. And 2 is a common factor of all 3 terms. It is the biggest number we can divide all 3 into. If I divide 2 out of our 4x squared, 4 divided by 2 is 2. And we still have our x squared term. Plus 6 divided by 2 is 3. And we still have our x. Minus 18 divided by 2 is 9. Now we can move on to our 2 sets of parentheses with 3 spaces. Since the third term is negative, the signs are opposite. Opposite, yep. If the third term is positive, the signs are the same and match the sign of the middle term. Now we need to find the factors of the first and third terms. So our factors of 2x squared, our first term, well, the only factors of x squared are x and x. Our only factors of 2 are 2 and 1. We only have one choice. So we're going to put 2x and x. Now our factors of 9 are 1 and 9 or 3 and 3. Which one do we want to try first? 3 and 3. And then we can check and make sure we have the correct factors. Now 2x times negative 3, 2 times negative 3 would be negative 6x. 3 times x is going to be plus 3x. And negative 6x plus 3x, negative 6 plus 3 is going to be negative 3. Is that the middle term we wanted? Well, yes and no. It's the correct number, but wrong sign. And if we have the correct number, but wrong sign, all we need to do is flip the signs. Because if we flip those signs, 2x times positive 3 is now positive 6x. Negative 3 times x is negative 3x. Now we do have that positive middle term of 3x. Questions on this here before we start solving them for x? Since we do have 2 things multiplied together to equal 0, one of these 2 expressions will be 0. Now the 2x minus 3, the first thing we can do is add 3 to both sides. Because our negative 3 plus 3 will simplify, leaving us with 2x equals 3. Then we would divide both sides by 2, telling us x is equal to 3/2. So that's one of our solutions. The other solution is going to come from x plus 3, and we would subtract 3 from both sides. These would simplify, telling us x is equal to negative 3. It'd be our other solution. However, negative 3 is a what? Restriction, which means we throw it out, we cross it out because it does not work. Y'all have a good rest of your day.